So in the previous video, we talked about the range of values from having either rounded or chopped. In this video, I want to talk about average errors. Okay, so we were looking at a number which has been rounded to 2 decimal places, in which case we get 3.82, and the range of values was between 3.815 and 3.825. With be careful with the inequality symbols here. And if it had been chopped to 2 decimal places, then the range of values would be between 3.82 and 3.83. Okay, so consider this on a number line. So here is 3.815 and here is 3.825. Okay, so as long as the number was greater than or equal to this number and less than this number, then what we would do is we would be rounding it to 2 decimal places and we would get the number slap bang in the middle, which is 3.82. Okay. So if you're thinking about what is the average error, well, because 3.82 is right in the middle, okay, the chance of the actual number being above or below that figure would be the same. Okay, so if that is the case, then the average error of this would be 0. So the average error when rounding is going to be equal to 0. Okay. But what if we've chopped it? Let's have a look at a number line. So here's 3.82 and here's 3.83. Now, if the number has been chopped to 2 decimal places, then it must be greater than or equal to 3.82, but less than 3.83. So anything in between here, apart from that end point, okay? And the number that you get through chopping is 3.82. It's not right bang in the middle this time. Unlike for rounding, which is right in the center of your 2 bounds, for chopping, it's right on the left-hand side. So the consequence of that is that if you're looking at the average error, it's not going to be 0, because what's going to happen is that it'd be very unlikely that it is actually 3.82. The exact value is going to be somewhere here. Okay? For rounding, it could be anywhere here. And all of these values would average out to 3.82. And so the average error would be 0. Over here, that is not going to be the case. So the range of error in this case, so that range of error, is equal to that distance. So 0.01. Okay, so, or 0, let's write it as 0 to 0.01. The range of error goes from 0 all the way up to an error of 0.01 if the exact value was up here, right? So that means that the average error is going to be equal to halfway between those 2 values. So there, and that would be at 0.005. So on average, the error that you're going to get from chopping will be that added on to the 3.82. So it's 0.005 away from the 3.82. So you'd expect that all those errors, if you added them up and averaged them out, would get you this average distance. So halfway along your number line.